These are your 12-2A notes on angles and angle measures. We're going to step out of the right triangle and we're going to move into angle measures on the coordinate plane. And so we have some terminology here. Standard position of an angle is where the angle has a vertex at the origin, 0, 0, and the initial side on the x-axis. So the initial side is the ray of the angle that's fixed. It does not move. So this side always stays along the positive x-axis. So it starts at 0, 0 and then moves along the positive x-axis. And then the terminal side of the angle is the ray of the angle that rotates around the center. And so it can rotate clockwise, it can rotate counterclockwise, and it can go around and around over and over and over again. And so what I have here is a picture of different angles. And I have the quadrantal angles labeled. And a quadrantal angle is the angles that make the quadrants. That's why they're called quadrantal angles. And so it's when the terminal side lies on one of those particular angles. And I know I don't have 0 here, but 0 would be like if the terminal side was closed and it was right on top of the other side. Now I know there's some, there we go. So what I have here is I have the vertex at 0, 0. And I'd actually like you guys to draw the initial side. The book doesn't put it in there, but I'd like you to understand that there is a ray on the x-axis. It just doesn't show up. And then that red arrow is a directional arrow. That's really important. It's a critical part of drawing these angles. It tells us direction. So this tells us that it's opening up counterclockwise, and that's a positive angle measurement. And so the terminal side in this particular case is in the second quadrant. And the quadrantals are all the other degrees. The only quadrantal that didn't show up is like 0 degrees. This is quadrant 1, just to review. This is quadrant 2, quadrant 3, and quadrant 4. We use Roman numerals to number the quadrants. So we're going to talk about 3 different angle measures, and then we're going to draw these angles. The first one being the positive angle measure. So that's when the terminal side rotates counterclockwise about the center. So if we're in standard position, we have here's our vertex of our angle, here's our initial side along the positive x value. And give the example of 220 degrees. Well, this is 90 degrees, this is 180 degrees, and this is 270. So we just kind of approximate. I'm not going to have you guys use a protractor, but you need to be roundabout. So we're beyond 180 degrees. Okay, we're not quite halfway. So we're just right about here. Okay, now to make that perfectly 220 degrees, positive 220 degrees, I need to show that directional arrow going counterclockwise, and then we're going to label it 220 degrees. And that takes out any doubt. It's not 225 or 223 or 230. It's 220. So I need that directional arrow along with the label when you guys are drawing these today. A negative angle measure, you could probably guess, is when the terminal side rotates clockwise about the center. So we're going to move the opposite way around this circle. So when we move opposite way, the quadrantals also show up in an opposite direction. So here's my initial side. This would be 0 degrees. This would be negative 90 degrees. This would be negative 180 degrees. And so to move a negative 170 degrees, we're also in quadrant 3 again. And we're just 10 degrees away from, we're almost 170 or 180 degrees. So we're just below the 180 degree mark. To make that perfect, we're going to show the directional arrow that I went clockwise, and I'm going to label it as a negative 170 degrees. So the opening is 170 degrees. I want you to understand that a 170 degree angle and a negative 170 degree angle are the same size. It's just the negative tells us the direction it's going. It changes the direction. Coterminal angles, actually I have an example of coterminal just on the positive and negatives. If you look at positive 270 and negative 90, those two angles are considered coterminal angles because they have the same terminal sides. When they're in standard position, they have the same terminal sides. And so in this example, I'm going to show you one that goes around more than once to show how to label that. And these are two positive coterminals. So coterminal can be two positives, two negatives, a positive and a negative. It doesn't matter. They're endless. There's an endless supply of coterminals. And so my initial side is here. To go 405 degrees, you got to do a little bit of calculations with your calculator. All the way around a circle is 360. We've got 90, 180, 270, and 360. So I need to know how much beyond 360 I need to go, just for planning purposes. So if I quickly just do this calculation, and I've got 405, take away 360, I'm at a 45-degree angle, which I know is right in the middle of that actual quadrant. I could have also cheated and just looked at the coterminal. So when I do this, I'm going to draw it smack dab in the middle. But when I label it, I need to show that I went around once. So I think of this like a hand of a clock. It keeps going around and around. Counterclockwise because it's positive. So I went around once and then some. So you just swirl it around, label it as 405 degrees. But it's also coterminal then. If I didn't know we went around once, 45 degrees is the same thing. I could have also gone around all the way around to 315 degrees in the negative sense. That would also be coterminal because it would land at the same spot. So in the end, how you get to the same spot over and over again is either you're going to add or subtract 360 to get coterminal angles. You may have to do it more than once, but that's what you do to get to coterminal. So let's go ahead and draw these three angles, and then we're going to find three coterminal angles. So to draw an angle with the given measurement, 210 degrees. 210 is a positive measurement. There's my initial side. It helps to label your quadrantals, knowing that I'm going to be in the third quadrant. And you could do some math quickly on your calculator to know that we're about 30 degrees in the third quadrant. So we're just beyond the 180 to make it perfect. We show our directional arrow. Make sure you put an arrowhead on it. It means nothing if it's just the loop. And then 210 degrees. For a negative 45 degrees, I got to go clockwise. So I'm going to start with my initial side. Here's negative 90 degrees. And so a negative 45 would be right smack in the middle of quadrant 4. To make it a negative 45 degrees, I'm going to show my directional angle and my label. 540 degrees. If I do some quick math, 540, I know I'm going around 360 degrees. And so when I figure that out, I'm also an additional 180. So I go around once and a half. So here's my initial side. I'm going to end my terminal side at 180. But to show that I went around once, I need to show I loop around once and then a half, 1.5 times. 540 degrees counterclockwise. And then coterminal, same exact degree measurements here. For our coterminal angles, we're going to find one positive and one angle negative. So you can have both positive and negative coterminals. It's endless. You just keep adding and subtracting 360 degrees until you get your positive and negatives. So 210 degrees plus an additional 360 leaves me with 570 degrees. There's a positive coterminal. And then to get my negative coterminal, I'm going to take the 210 degrees and subtract 360 from it. And I end up with a negative 150 degrees. Those are the most common. I mean, if you really wanted to do it more than that, I would accept those answers. But those are the most common two answers right there. For the negative 45, same thing. I'm going to do negative 45, and I'm going to add 360 to it. And that leaves me with a positive 315 degrees. To get my negative coterminal, I'm going to subtract 360 from it. And I end up with negative 405. And there you have it. And then the last case would be 540. Now, 540 is already over 360. So in this particular case, you're more than welcome to add 360 and subtract 360. But to get your negative, you're going to have to do a couple subtractions. So I'm actually going to subtract twice. I'm going to subtract 360 to get a coterminal 180. Then I'm going to take the 180 and subtract 360 again to get into the negatives. Otherwise, I would never get to the negatives. So that's the answer I'm going to give. I know it's common to just kind of get into a routine and add the 360. So if you added 360 to the 540, it just means you have a larger coterminal. I would be okay with 900 as well. I always check coterminals. If you're not giving me the exact same answer that I got, I always check to make sure that it wasn't just that you went a little bit further ahead. You could add 720. That just means you're adding, going twice around. All right, so your lesson summary here is I want you to draw me and label a beautiful negative 300-degree angle. And then I want you to find one positive and one negative coterminal to that negative 300 degrees. Good luck.